Okay, Year 11, yesterday we looked at errors. Today we are going to have a look at techniques that you can use to detect errors in your code. Lots of techniques can be used to check for errors in code before final production. These are those techniques. Here's the ones I use IRL. Stubs, flags, debugging, desk checking. And actually, that one. Peer checking, yep, good sometimes. Drivers, no, never. The best way I can explain a stub is like some dummy data that's imitating something else. So say, for example, graphic designers, when they want to just see the layout of a page, use a font called Lorem Ipsum, which is just this same sentence over and over and over again. And it will get them an idea of what it would look like to have font in there before they have words. That's kind of like a stub. You use stubs, a stub is a subroutine. It contains dummy data that you use until you have the actual data. So, for example, if you were creating a program that was dealing with people's names, but Jim Bob Jones in marketing hasn't actually given you the final copy of names yet, but you still want to test your data, you can use a stub. So a subroutine that just contains fake data, just so you can test other subroutines. Then you can go back later and actually use the actual data. It's a way of testing before you have any information. Or if you don't want to corrupt the information that you currently have. We've talked about drivers before. This is a different type of drivers. We've talked about system drivers or operating system drivers that connect a piece of hardware in your computer to the operating system. This is kind of similar to that, and it's a subroutine written as a middleman or to connect one or more other subroutines. Example of a driver is a subroutine, and you set all needed variables. Okay, you call whatever subroutine requires testing, and you output the result. Okay, it's used a lot of the time when a higher level. It's used a lot of the time when projects are done bottom up. So the lower subroutines or the less important ones are coded before the really important or big ones. In that case, you can use a driver to check for errors. Okay, flags. Flags is a super important one. Flags are a really easy way to error check, and they're basically used to indicate if a condition has been met. They're commonly Boolean or true or false. So for example, if you had, like we did in the half yearly, if you have someone entering a PIN, okay, and then once they've entered the PIN, they get an option to check their account balance or withdraw, you'd want to include a flag called valid, and you'd want to set the first condition for that being able to check PIN or valid to being if valid equals true. Valid in this circumstance would be being used as a flag, okay, and you can also use flags in error checking to just actually see if a subroutine is actually executed, okay, or if it maybe for some reason hasn't. Debugging output statements is really important. Instead of waiting to the very end and you going, oh, well, that's not the outcome I've expected, going back through your code, and every time you manipulate a variable or you do something, print out that answer. You might have seen me doing this with some of you. Just going, oh, just print that to the screen, just tell me what that comes out with, rather than doing all the hundreds of executions and then going, oh, my answer's wrong, but rather going back and printing things to see if you can isolate the issue. It's often used in conjunction with stubs and drivers and flags. Desk checking is a really important way of error checking, and I haven't gone through it very well, so I'm not going to go through it in this video. If you want to pause and have a look at the next like 20 seconds of slides, you're welcome to, but I'm not going to detail it here because I'll go over my time. Okay, peer checking. Here, these are the easy ones. Peer checking. Get someone else to look at it. Oh my God, my code's not working. Can you just look and see? Oh, yeah, I see it. It's there. Someone else looking at your code tends to be a really good point. Extra set of eyes tend to help. And use of expected outputs. This is what I did today with those averages and your 420s and 69 numbers when we were trying to work out what was logically wrong with that average counter. I actually calculated at IRL. We got the calculator out and said, no, it's not working. Okay, and we checked to see if my output was actually what I'd intended. That's a really good technique.